Yeah, that's it. Just add and subtract 360. That's all. What's the next group? And then conversion. If I go through conversion, if I want to convert 7 pi over 3 into degrees, all you have to do is multiply it by 180 and then divide it by pi. So what happens then is that pi's drop. 3 goes into 180, 60, and you wind up 420 degrees. You're not going to get a calculator. Stop relying on it. You have to stop relying on it. You can push me all day long. You have to stop relying on it. Well, good luck then. Yes, ma'am.
I followed you up till the pies drop.
What's pi divided by pi? 1.
Right, I got that part. What comes
3 goes
after
into
that?
3 goes into 180 how many times? 3 goes into 18 how many times?
6.
So it'll be 60. 60 times 7 is 420.
Okay, so
The radian, to go from radian to degree, take your radian value, multiply it by 180, and divide it by pi. What'd you get, Miss Stephanie? What'd you have? Yeah, what'd you have? You have a question?
I was wondering if 180 over pi was kind of like a 1 that the pi was also like as a way to like take out the pi's that you
Yeah, because remember, degrees don't have pi's, and pi's don't have degrees. 420 degrees. Don't use your calculator.
Oh, no, I was just double checking. What about the 7?
What's 7 times 60? Done.
Done.
Don't duh her. Only I can.
No, I can look. You cannot.
Yes, ma'am.
so this one we don't have to
Just conversion. It's just conversion. Okay. It's just conversion. And again, the idea here is that you guys freak out. If I want to take 7 pi over 8, and I want to convert that to degrees, again, multiply it by 180 and divide it by pi. That drops. 180 and 8 are both even. 4 and 90 are both so 7 times 45. Well, what's 7 times 5? 35. What's 7 times 4? What's 28 and 3? So 315 pi, 315 over 2.
you're killing me.
Or half of 315 would be 1. Oops, sorry. Okay. Simplifying fractions. Converting things back and forth. All right. Radians, like I said a little yesterday, radians are very, very easy to use once you get accustomed to how they're placed and how things are worked. Once we get past the idea that radian is scary, and this might alleviate that. This is what? At 90 degrees. Half of pi. Pi over 2. And this is 3 pi over 2. In trigonometry, we're only really going to worry ourselves about 3 different angles. 30s, 60s, and 45s. Because we know how to solve for them. So what we need to do is figure out the radian values of 30, 45, and 60, and I'm going to show you how these things place themselves in. So let's do this. You need a space on your paper, probably about a 4x4 square, so we have a little bit of room. Okay. Would be 1 by 1 if you're going with a 4x4 square. There's 4 quadrants. So what we're going to do is we're going to create angle measures for a unit circle. Okay?
It's a beautiful circle.
And I'm going to show you guys how all you need to know is how to find the radian value of 3 angles. Okay? Smallest of the 3 angles is going to be 30, 45, and 60. Agree with me?
Yes.
Okay. To convert degrees to radians, take degree divided by 180 and slap a pi next to it. 30 over 180 becomes 3 over 18. Agree? Okay. What is that? 1/6. So 30 degrees is going to be pi over 6. I'm going to go to the 60. What do you know about 60 degrees in relationship to 30 degrees? It's double. So what's double pi over 6? Pi over 3. You double pi over 6, you get 2 pi over 6. Pi over 3. So in essence, did I only really need to find 1?
Yes.
Okay. Because we know where 90 is. 90 is pi over 2. Is it 45 half of that? What's half of a half?
Over 4.
So it's pi over 4. You okay with that?
Yes, sir.
I like to skip the second quadrant because I think it's easier to bounce this to the third quadrant right away, because when I move these, all I did was took this angle here and I added 180 degrees to it to get to there. So I added 180 to 60. Well, what's 180 plus 60? 240. If I add 180 to 30, what is it? 210. If I add 180 to 45, where am I? 25. Notice 30, 45, 60, they go up by 15 degrees. 210, 225, 240, they go up by 15 degrees. If I added 180 degrees to get to that other quadrant, I would have to add pi. So what's pi plus pi over 6? Oh, think of it in terms of part and a whole. 1 over 6 plus 6 over 6 is 7 pi over 6. Add a whole to a quarter.
Oh, I see.
Um,
I'm adding I'm adding 4 over 4 to 1 over 4, and I get 5 pi over 6, or 5 pi over 4, excuse me. I'm adding pi, because I went 180 degrees. Okay? Add pi to pi over 3, 4/3. So it's 4 pi over 3. That gives you those angles. Now I want you also to notice is that from 180 degrees to 210, it bounced how far off? 30. It was down 30 degrees. It was down 45 degrees. It was down 60 degrees. Each one of these has what's called a reference angle. How far did it bounce off the x-axis? Reference angles will always be positive, and they're always going to be the distance from an x-axis. Whether you're in the third quadrant, you're coming up. If you're in the second quadrant, you're coming down,
Again,
or the other two.
interruption, the drill is now over. You can get out of the lifetime. Thank you.
Good job, guys.
We didn't die.
Okay. So far, so good. Now, what I want you also to see is that if I'm at 30 degrees and my point lies on the unit circle, it therefore then has a place in space. It has an x and a y value. It has some horizontal and some vertical distance. Well, in that grid, in order to calculate that, you'd have to drop a perpendicular to create a right angle. Therefore, I create a 30-60 right triangle. And I know my opposites and my adjacents and all that stuff from that, because this would have to be a 1, this would have to be a root 3, and this value would have to be 2. So in order to figure out where things went in terms of ordered pair, the horizontal distance, the vertical distance, that gives you your cosine and your sine values. That gives you your x and y value. Your x, y value here is cosine sine. What's the cosine of 30 degrees? It's root 3 over 2. What's the sine of 30 degrees? It's 1/2. Yes, sir?
So this is just used to calculate points on a circle?
No, this is how you get the ordered pairs. It all comes from special right triangles. Because watch what happens here. Both ordered pairs, your x and y values in the first quadrant are both positive. Everybody okay with that?
Yep.
What happens when I take this ordered pair and I place it here, because this still has the exact same reference angle of 30 degrees? Negative, negative. They both become negative. What happens if it gets placed in this quadrant with that same 30-degree reference angle? Negative, positive. So basically, as I'm starting to show you guys, we only really had to do one calculation to start the unit circle. What's the radian value of 30 degrees? Everything else comes off of that. Because you know what half of a half is. You know how to double a third. Everything else is the same. All you have to do is start with one value, radian of 30. It's pretty cool. Says the math teacher. Okay. Same thing here. If I take my 3 angles again, and I'm going to use what's called, yes ma'am? Radian value of 30 degrees. 30 over 180, slap a pi next to it. 3 over 18 is 1/6, so it just becomes pi over 6. Yes ma'am?
I don't know why it's really just
What's of 7 pi over 6? I'm taking 1/6 pi and I'm adding 1 pi. When you add fractions, you're adding common denominators. 6 plus 1 is 7. That's all. Okay. Just adding fractions. Now, going back to the second quadrant. When you're coming around, I'm going to show you guys again via a reference angle. If this ordered pair here is to match to this ordered pair here, the only thing that changes is the sign SIGN of the x coordinate. You agree on that? The x value becomes negative, the y value stays the same. Therefore, these two triangles that are created are congruent that way via the angle here. Because you still have the same, it's just reflected, excuse me. So this is a 30-degree up, which means what's 30 degrees up from 180? 150. What's pi over 6 up from pi? What's 1/6 less than a whole? So this is 5 pi over 6. What's 45 degrees up from 180? 135. What is a quarter, oops, here. What is a quarter less than a whole? What's 60 degrees up from 180? 120. What is 1/3 up from a whole? 2/3. What do you think I'm going to do to those 3 ordered pairs in the 4th quadrant? Not ordered pairs, excuse me, those values. Add 180, add 1 pi. As I drop them through. I am now 30 degrees off of the x-axis. So 30 degrees away from 360 is 330. 45 degrees away from 360, 315. And then 300. 1/6 away from a hole, 2 holes. 11/6, very good. 11 pi. 1/4 away from 2 holes. Remember, 2 hole, if you're talking about 2 pi with the fraction of 4, it would be 8 pi over 4. Subtract 1 from it, you get 7 pi over 4.
7 pi notice.
What's that?
7 pi notice.
You wouldn't understand.
Yes. And then
He got
lastly, if I'm, yeah, or you can subtract 1/3 from this, or you can add 1 pi to that, and you get 5/3. Radian value really only has to start with 30 degrees. Okay? You okay?
That looks
You're
nice.
dozing off on me here. What's that? Sorry to hear that. Now, big picture thing here, guys. Is this something that you have to have totally nailed down and memorized?
No.
Not really. Because if you can place an angle in space via reference angles and spin them around the right direction, and you know how to convert radian value, it's very, very easy to utilize. It's extremely easy to use. Okay? I've got a chart that I'm going to give you guys in the next day or so to help continually build and work through. Yes, sir?
I'm not an astronaut yet, so probably
He's gonna think you He just wants
What year do you graduate?
next year.
For real, or not sure you're real?
I mean, I have 2 classes. I've got 2 classes. I could be graduating at the end of this year.
I'm messing with you. I'm just messing with you.
No, you're I'm gonna report you to the bully box.
So, guys, really, this is one of the biggest concepts that we talk about in Algebra 2 and the relationship between angles and degrees and all that stuff. How we're going to be able to get our ordered pairs and move stuff around in space. But it all stems from bouncing quadrants. Okay? Everything bounces a quadrant. So the other, did all this, blah, 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 blah. Last little bit is something you guys would probably be happy to see. Arc length and area of a sector from the circle chapter last year, which probably gave you guys the heebie-jeebies. Did you guys have your take-home test, your take-home quiz for that?
Yeah.
Oh, that thing was nasty. God, I love that quiz. I love that test. So, last year when you guys did arc length, you might have done it like this. Central angle over 360 times 2 pi r. That was arc length. Now, if I'm looking at this in terms of Algebra 2 now, simplify that. What's 2 over 360? 180. So you get angle over 180 times pi times r. Wait a second. When you have angle over 180 times pi, what is that? Radian.
Gradient.
So it's the radian value times r. We have time. I will show you the movie clip for RAD. Oh yeah, sir, you guys saw
Let me see it again.
Yeah,
Let me see it again. That was great.
It's radian times your radius. And they use radian, they use theta to show radian value. So if you have a radius of 6 and an angle of 120, let's say angle is 120 degrees, what is the arc length? Well, what you guys did in the past, you do 120 over 360 times 2 times pi times r. Well, now you just convert it right to a radian and multiply it by your radius. 120 over 180 times pi times 6. Now watch this. You're going to be happy. Zeros. 6 goes into 18 how many times? 3 goes into 12 how many times? 4. Your answer is 4 pi. Go to the next problem. You did this last year. You just didn't know you were converting things into radian. You just didn't know that's what you're doing.
Wait, Mr. Charles. 6 is under 12 twice.
Yeah.
No, you can do the denominator.
6 goes into 18,
2 times.
right? And then 3 goes into 12 4 times.
3 goes into, okay, actually, I thought you said 6 goes into 12.
No.
Oh.
6 was the numerator. I didn't change the laws of math on you there. Okay.
You should.
And then if I want to find the area of the sector, the area of the sector was central angle over 360 times 2 pi r squared. Well, isn't that just radian r squared?
Yep.
Oh wait, wasn't there something else in there? There was like a half, I thought.
One half.
There is one half
Yes,
with the first
there was something in here because I thought you had to do that too.
one. Are you sure?
I don't remember, but I know the formula works out to be. So then we don't do this anymore. We do 1/2.
I'm not paying attention. I'm paying attention.
Laughing, jerk.
I'm paying attention.
It's 1/2 r squared times theta, where theta is rad.
It's like the-
You just convert it to radian. Okay.
So,
Radian joule.
Good guy. He's gonna kill me.
Do you know that every time you say that little angle thing, I think of my girl because her name was Beta, and it's like really close.
So if I do the same thing where I want to find the area of the sector where it was 120 degrees and the radius was 6, 1/2 120 over 180 times 6 squared pi. Oh, let's do this. That's 6's, so that goes what, 2 and 3. 2's go. 36 pi over 3 is 12 pi. Yeah, it's on square. Unfortunately, I have found it over the course of years that fraction work has been lagged upon at lower level.
What does that mean, Mr. Murphy?
You guys don't have a lot of practice using simplifying fractions.
questioning my fraction. Oh, okay.
That's the whole problem, right? Okay. Zeros drop. 12 over 18 is 2/3.
Right.
Yeah, I believe you.
2's drop.
Oh.
Now I have 36 pi over 3. exciting. Bless you. It's rad difficult. Yes, ma'am. Why is there a pi with it? Because I couldn't simplify it out. Formula has a pi in it for the area of the second. It's the portion of the circle. And the area of the circle has the pi r squared, so you have to put that below. Yes, sir?
Where did the equals sign come from?
That's the answer.
Okay.
All right. So same stuff you guys were working yesterday. It's what, 28 through
51.
Well, but 51 had all the degree ones. So go 28, 43 radian. And then it'll be 52 through 65.
Gee, man, that's a lot of problems.
We just arranged these.
Yeah, the 28 to 43 is just the ones with pi in it. So it's just the radian ones. So it's the whole idea of drawing the angle, finding the coterminals. And then the 52 to 65, the 52 parts were converting radians to degrees. And then the last 6 problems are find area of sector, area, and arc length. And that's just all in radians. So that's why we didn't have that last night. Okay? That's more than 5 minutes. You've seen it already.
Good thing I have all this homework to keep me busy.
I mean, I guess
No,
not.
hands.
Good thing I got all this homework to keep me busy. Dude, this is way cool.
It's a very good thing. I worry about your well-being. You're welcome.
I don't want to break myself.